Today we will be discussing molecular formulas. Molecular formulas are going to be my true or my real formulas for any compound, and converting between my empirical, which is my most simplified, and molecular is very, very easy. So you might be given an empirical formula just straight out, or you might be asked to find it. Both are viable. Regardless, once you actually have the empirical formula, that's when you can go ahead and start moving on to the molecular formula and figuring that out. Step 1 is going to be calculating the molar mass for the empirical formula. Again, like I said, you do need that empirical formula before you can move on, but the molar mass for the molecular formula should be provided within the problem. So all you need to do is calculate the molar mass for the empirical, divide the molar mass of the molecular formula by that of the empirical that we calculated in step 1. And then whatever number that comes out to be, we're going to go ahead and multiply the subscripts by that number. And then we'll plug in our new subscripts. Those new subscripts are going to be my real subscripts, my molecular formula subscripts, and we're going to go ahead and do an example. So the example that I am going to do, I see a compound has the empirical formula of CH2O and a molar mass of 120.10 grams per mole for its molecular formula. And then I ask, what is its molecular formula? So this example goes ahead and gives me the empirical formula. Like I said, you may have to actually figure out the empirical formula, but remember that's really simple. Percent to mass, mass to mole, divide by small, multiply to whole. Go back and watch the empirical formula video if you need to. But since we are just given it, we can go ahead and move on to step 1 and calculate the molar mass of the empirical formula. So I went ahead, I have each subscript for each different element, and I'm multiplying it by the mass from the table. I'm getting those all together, and then whenever I add that up, I get the number 30.026 grams per mole as my molar mass for my empirical formula, which was at CH2O. Step 2, I'm going to go ahead and divide the molar mass of my empirical by that of my molecular. My molecular molar mass was provided in my actual question, so I am going to be dividing 120.1 by the new number that I just found, the 30.026. When I did that, I got the number that was close enough to round to 4, and that meant I could go ahead and multiply all of my subscripts from my empirical formula, which was 1, 2, and 1 respectively, by 4. And so I did that. And then I can go ahead and add them to my actual compound. So carbon's new subscript is going to be 4, hydrogen's new subscript is 8, and oxygen's new subscript is 4. And that is my molecular formula, or my true formula for this compound.